Motion is a fundamental aspect of the universe, observable in various forms. Cars speeding down a highway exemplify linear motion. A pendulum swinging rhythmically demonstrates oscillatory motion. The Earth orbiting the Sun illustrates circular motion. These examples demonstrate the ubiquity of motion in different scales and contexts. Motion is present everywhere, from macroscopic objects to microscopic particles. Motion varies in path and predictability, encompassing a range of types. Linear motion involves movement along a straight line. Rotational motion describes movement around a fixed axis. Oscillatory motion involves repetitive movement back and forth around an equilibrium point. Rectilinear motion is defined as movement along a straight line. An example of rectilinear motion is a car traveling on a straight road. In rectilinear motion, the object maintains a constant direction. Visualizing linear movement helps understand rectilinear motion. An object exhibits rectilinear motion when it moves without any change in direction. The defining characteristic of rectilinear motion is its straight path. Absence of directional deviation is essential for rectilinear motion. Rectilinear motion is characterized by constant velocity in a single direction. Now, let's talk about circular motion next. Circular motion is defined as movement along a circular path. The Earth's orbit around the Sun exemplifies circular motion. The Earth continuously traces a circular orbit around the Sun. The circular path is maintained by a centripetal force. Circular motion is defined by an object's trajectory following a circular path. Objects in circular motion maintain a constant distance from a central point. The radius of the circle remains constant throughout the motion. The speed of the object can be constant, but the velocity is always changing due to the changing direction. Circular motion is a fundamental concept in physics, applicable to many real-world phenomena. Understanding circular motion is essential for analyzing rotational systems and their dynamics. Next comes oscillatory motion. Oscillatory motion is defined by repetitive back-and-forth movement around a central equilibrium point. A swinging pendulum exemplifies oscillatory motion, exhibiting continuous movement between two extreme positions. The pendulum's motion involves a constant exchange between potential and kinetic energy during each swing. The period of oscillation is the time required for one complete back-and-forth cycle of the pendulum. Factors such as pendulum length and gravitational acceleration influence the period of oscillation. In ideal oscillatory motion, the amplitude remains constant, but in reality, friction causes the amplitude to gradually decrease over time. Oscillatory motion is characterized by repetitive back-and-forth movement. Objects in oscillatory motion return to a central equilibrium point after each swing or vibration. The motion repeats itself over regular time intervals. Examples of oscillatory motion include a swinging pendulum and a vibrating spring. Oscillatory systems possess kinetic and potential energy that continuously interchange during motion. The frequency of oscillation is determined by the physical properties of the system. Random motion describes unpredictable and irregular movement. Gas molecules collide with each other, resulting in changes in direction and speed. These collisions cause gas molecules to bounce off each other in chaotic paths. The average speed of gas molecules is related to the temperature of the gas. This random motion is a fundamental property of gases. Random motion is exemplified by a butterfly's flight path in a garden. The butterfly's path is erratic and unpredictable. A butterfly's flight showcases random movement. Motion can be categorized into distinct types based on the path an object follows. Straight motion involves movement along a linear path from one point to another. Circular motion describes movement along a curved path, forming a circle or arc. Back-and-forth motion or oscillatory motion involves repetitive movement between 2 points along a line. Random motion describes unpredictable movement without a defined path or pattern. Understanding these motion categories aids in analyzing and describing object movement. Observed motion types frequently encountered in daily life reinforce learned physics concepts. Linear motion is commonly observed in vehicles and objects moving in a straight path. Rotational motion is evident in spinning objects such as wheels and rotating machinery. Oscillatory motion is demonstrated by objects moving back and forth like a pendulum or a swing. Complex motion often combines linear, rotational, and oscillatory movements. Please like, subscribe, share, and hype for more such insightful contents.